it's often underestimated how much time it takes to sort it out. And it's the 80-20 rule very much applies, or maybe it's the 90-10 even, that you can make great progress very quickly, but it's the long tail. It's the long tail of edge cases that take all the sorting out. So, for example, we try and automate as much as possible by running scripts and regular expressions, simple stuff. But then in a control system, you find there's a whole load of information that's not on the drawings. And that's because it has internal data that's used for, say, calculation of something. And an example we had was a flare metering package. It had all its own internal information that was never passed outwards, but was available if we wanted it. And the tagging, the naming of this information didn't match anything anywhere. And so none of our scripts knew what to do with it. But it wasn't until we found the engineer for the flare package who helped us understand how to unpick this, that we could sort it and knew where to assign it to things. So that's a simple example, I guess, of we made a lot of progress, but suddenly we hit these blockers. There's just the stuff sitting there that people need to go literally through. What's that? And unpick it by hand.
Yeah. Think of naming convention, and the only reason is because I suddenly shouted. Naming conventions. I've sat in many meetings. Naming conventions over data points. It's like, and then everyone having to agree. But I think there's just so many different parts of sorting out data and agreeing it. I think it becomes a very arduous. It can become a very arduous task. That's important.
It can do, and actually it makes me think of an important point, that there was a drive for standardization, and there is the standards, and trying to make new projects certainly consistent. But when you've got brownfield projects that have different naming conventions, you're never going to be able to go back and update them all to some standard. So you've got to find a way of moving forward and tolerating that mismatch. And that's why something we do in the data model is a lot of aliasing. So being able to say, this is its name, in this system it's called this, in this system it's called this, so that users can interact with it in a consistent way, and it handles the mapping to the different names. And that's why I'm big on things like a class library.
Okay.
Being able to say at some point, these are actually the same thing. Yeah, they're called different things, but you can treat them the same.
So is that with that, you say it's quite similar to a data dictionary then? Before?
Yeah, could well be. Yeah.
Okay. Yeah. I'm just thinking, because often that needs to be in place before that data model is built, because that feeds into that data model, doesn't it?
It does, and actually that's what we tried to do to start with, but it held us up too long. So what we've ended up doing is applying it retrospectively as much as possible. Right. And so we end up in some sort of happy halfway house where you apply the class library as much as you can, but some things don't fit. And so anything that needs to have a rigorous class library in place will work on the bits of the data that have been classed or typed, and other bits just it won't work on, but that's maybe okay. Yeah. But you have to find a way to move forward.
Yeah. So that all problems are solvable and nothing is unsolvable.
That's right. Yeah. And you can, if you need something included that's not been typed or classed, then you can just extend it and add that in when you need it. You don't have to wait till you've done everything before you get value out of it.